Welcome back. We are now in objective 2.2. We're moving on to the next kind of skill that you're going to need to learn to be successful in this unit. Our goal is still to understand the derivative and to be able to evaluate it. But so far we've been doing it the long way. After this lesson, you're going to learn how to evaluate derivatives algebraically and numerically using rules. Specifically for this lesson, though, we are going to learn about the power rule and other basic rules. So the goal is that by the end of this lesson, you will be able to take a derivative without using the long process of the definition. So let's get started. Feel free to pause the video at any time and slow down the notes or repeat them whenever you need them. So I start with the first rule, taking the derivative of constants. So remember the way I have this set up here means this is a command, take the derivative of what's inside. Now C is going to represent a number, any number that you would like. And what this is going to do is say that anytime you take the derivative of a number, you're going to get the same result. And that result is going to be 0. And let me give you an example. Let's say I have y equals 3. If you find the derivative of y equals 3, that would be y prime. The derivative of 3 is going to be 0. Now, we've kind of touched on this in class, but let me remind you why. If we were to graph y equals 3, you would remember or know that it's going to be a horizontal line. It's going to be a horizontal line that goes through y equals 3. Well, if we're trying to find the slope of the tangent line on this line, well, the slope of the tangent line will be the slope of the line, and the slope of the line will be 0. And it doesn't matter where you put this line. You could move it up or down. You can put it at -1 if you wanted. The slope would still be 0, meaning that if your function is equal to a constant, its derivative will always be 0. No matter what that is. I could put y equals 250. The derivative would still be 0. So that's one of the shortcuts. So in the notes here on the side, we're going to put constant functions are horizontal lines. So their slopes are always 0. Okay, that's an easy one to know. All right, so let's move on to the power rule, which is basically the most important rule for the lesson. Now, in a later video, I'm going to prove the power rule, but for today, we're just going to learn how to use it. So let's say that we want to take the derivative of x raised to some power n being a number. Before this, we would use the limit as h approaches 0 of f of x plus h minus f of x over h, and that is known as the definition of the derivative. Well, the power rule is a shortcut that allows you to basically do this process in your head. All you have to do is take this power and bring it to the front of the variable so that it's now n times x, and whatever this power is, you are going to subtract 1. Now, you might be thinking, give me an example, I'm a little confused. Let's say we had y equals x to the third power, and we wanted to take the derivative. In the past, we would set up x plus h to the third power minus x cubed. We would FOIL it twice, then combine like terms, cancel out, factor out an h, and 5 minutes later, hopefully arrive at an answer. What this rule is going to allow you to do is this. Instead of using the definition, let me change my color, you're simply going to drop this 3 to the front for the derivative. It's now 3 times x, and then we're simply going to subtract 1 from the power squared. So that's it. It probably takes you about 2 seconds, and you computed the derivative. Now, if you would like to pause the video and check it out by applying the limit, I encourage you to do that. But this is actually what it works out to. So let's try another one just to make sure that your eyes can believe what you're seeing and your ears can believe what you're hearing. Let's say we had x to the 7th power. If we were going to do a problem like this in the past, with the definition, that would be really, really difficult. Our setup would be x plus h to the 7th power. I don't know about you, but I don't want to FOIL this 7 times. So instead, we're going to use the power rule. And the power rule is very simple. You are going to take the power and drop it to the front. So it now becomes 7x, and then subtract 1 off, so 6. And you are done. That is the derivative. So you can see how this rule is going to be a game changer. It's going to change the way we do derivatives, and it's going to make it much easier. Now, does this work when the number is not a whole number? Yes, let's try one that is negative. So let's say y equals x to the negative 4. Okay, well, let's see. The derivative of that would simply be bring down your 4. Okay, and that will be negative 4 x to the, well, you have to subtract 1, and since it was already negative, here's where the rule is very easy. You just have to make sure you don't make any arithmetic mistakes. Negative 4 minus 1 is negative 5. Okay, so you got to be careful. Now, this is a perfectly good answer, but more than likely, if it's a multiple choice exam, they are not going to present this answer like this. They are going to fix that negative exponent by sending it to the denominator. And this is probably the way you would see it on a multiple choice exam. I will accept on a free response this first answer, but this is more than likely how you're going to see it on a multiple choice exam. Okay, so that would be, this would be your answer here. Okay, now on that same thought, let's say I had an equation like this. Let's say to the 4th here. Well, make it 8 just to change that power. This is technically a quotient. It's a division of two terms. You are not allowed to just take the derivative of the top and the derivative of the bottom. In a later video, I'm going to tell you how you do the derivative of a quotient. But this quotient is very easy to make it look like it's not a quotient. In other words, we can rewrite it before applying the power rule. Do not just try to apply the power rule when x is in the denominator. You have to have it as a single term that is in the numerator. So you cannot just say, oh, that's 1 over 8x to the 7th power. It doesn't work that way. Before you take the derivative, you have to bring this guy upstairs. There's already a 1 there. I'll just leave it there. It's going to be x to the negative 8. Now, once you've done that, it's no longer a quotient. It's set up as just a regular x to the negative 8 power. Now you can do the derivative. Okay, and again, you're going to bring the power forward. So it's going to bring this forward. And then you do negative 8, and then the x, and then you subtract 1, which of course makes you get to negative 9. And this is a good answer, but on a multiple choice test, more than likely you would see the negative 8 on top, and then they send that x to the 9th, negative 9 to the bottom. And it becomes positive because you've changed the location. All right, so here's another example. Now, something that you're going to see as well in your assignment is something with radicals. So let's try that. Let's say y equals the 5th root of x squared. And they ask you to take the derivative of this equation. Before you take the derivative, you need to make sure that you write this so that it is x to some power. After all, it is the power rule, so it has to be written in that form. Before you take the derivative of something this complicated, you need to rewrite this so that it looks like x to some power. Now, you may not remember, so this is going to be your review. When you have a radical, that means that your power is going to be a fraction. And the denominator of that fraction will be the index of the radical. So this 5 goes down here. And if you have a power here, if you don't, it's just a 1. But if you have a power, you write that 1 on top. So again, if you don't have a power, it would have been 1. So the 5th root of x squared is really x to the 2/5 power. Now, I haven't taken a derivative. I just rewrote it so that I have x raised to some power. And now let's get ready to do that derivative using the power rule. So I'm going to take my power and I'm going to send it to the front. And it will be 2/5 x. And now I have to subtract 1. Now here's where it gets tricky. It is a fraction, so subtracting 1 is the same thing as subtracting 5 over 5. You want to have that common denominator. 2 minus 5 is -3 over 5. This is a good answer, but if it's multiple choice, more than likely you are not going to see it like this. You're going to see a 2 upstairs, a 5 downstairs, and the x, because of the negative exponent, also downstairs, but now with a positive 3/5 as your power. So the power rule is very, very simple, but I do see people making a lot of mistakes when there's negatives involved, when there's radicals involved. So as long as you're very careful, you should be fine. Okay, so third rule is the constant multiple rule. And what that is going to say is, hey, if you have a constant, a number multiplied by a function, then how do you take the derivative? And that's very simple. You simply take that constant and you multiply it by whatever the derivative of the function would be. And so, of course, you want to see examples of that. Let me put them down here. Let's say that instead of just having y equals x to the third power, let's say we had 2x to the third power. And you have a 2 times x cubed, and that's that constant there in the front, also called the coefficient. Well, what this rule basically says is take your power and bring it to the front. You are now going to multiply by whatever is in the front. So I have 2 times 3x, and the derivative of it's 2 times the derivative of x cubed. The derivative of x cubed will be 3 to the second power here. So really this is just 6x squared. Now that was kind of a long way of doing it. A lot of people would just know in their heads, you're going to drop this to the front. It'll be 2 times 3, which is 6, and then subtract 1 from the power. So let's do another one just real quick. So let's say I had y equals, let's say 4x to the 7th power. Instead of that really long way, it's just kind of a long way there. I'm going to take the derivative in my head. I'm just going to drop this to the front. I know there's a 4, so 4 times 7, that's 28. And then I'm going to subtract 1, so x to the 6th power. And I'm done. Okay? All right, so that one just says if there's a coefficient, multiply it by that power. Don't forget to subtract 1 on the power. All right, let's do the last rule here, the sum and difference rule. The sum and difference rule, they're using the variable u to represent a function and v to represent a function. So if you're adding or subtracting a function, the derivative of that sum or difference would simply be the derivative of each function, and then either plus or minus, depending on what it is, the derivative of the next one. So let's do some examples of what that would look like. Let's say y equaled 7x squared plus 5x minus 2. So what's happening here is you have 3 functions actually. You have an addition and then you have a subtraction, and technically these are all, each term is a function. So to take the derivative, we are not going to panic. We're simply going to go one by one. We're going to apply the power rule to this first one. That would give us 14. If you subtract 1 from 2, you get just 1, which is x. You don't have to put the 1, but you can. Now, I don't see a power here, so I'm going to put a 1. And I'm going to drop it to the front, times 5. That's just 5. But if I subtract 1, that gives me x to the 0. And everybody knows that anything, or at least I hope everybody knows that anything raised to the 0 power is 1. So technically that's just 5 times 1, or 5. And from the very first rule, we know that the derivative of a constant is 0. So the derivative is simply 14x plus 5. And that's it. So this is what the sum and difference rule says. If you have a sum and difference, you basically take the derivative of each term, and that's the derivative of your function. In the next video, I'm going to go over the 4 examples that you see below. They're a little bit more complicated, just to give you extra support. Hope it made sense, and hope you have this in your notes.